Hi, this is a deep dive on how to find greener materials. It's actually not rocket science, it just involves a lot of digging around on websites and sometimes calling companies. Okay, let's start on the VentureWell website. There's the greener materials page here, and then this gives general information, but if you go to the Finding Greener Materials page, that is where it lists a whole bunch of books and catalogs and databases and chemical toxicity libraries. Now, the books, those are really good for general concepts, but they're usually not a great place to find what the newest cool materials are, especially when the books are 10 years old or more. So we're going to skip past those and go to catalogs of green materials. And I'll just use a couple examples here. So if we click on the Cradle products registry, this is just a list put together, or a database, by the people who run Cradle to Cradle certification, the Cradle to Cradle Products Innovation Institute. And you can see some various products that they have certified on the front page here. And more importantly, you'll see this whole list of categories in the left-hand sidebar. So if you're looking for basic materials, that's probably what you're looking for now, but also products by like the building industry or the fashion industry or office supplies or furniture, etc., packaging. So if we look at, let's say just basic materials. And so here are a bunch of things. So insulation or packaging material made out of mushroom mycelium, that's a fun one. Carbon black, various kinds. And just you can see all sorts of general stuff. So glazes for pottery, PLA NatureWorks called Ingeo, and there's all kinds of basic materials here. But there's also some basic materials in these other categories as well. Like if you look at design and furniture, then you can see there's upholstery and textiles. So that has a whole bunch of basic materials as well that might be good for your product. And if you click on any one of these, I'm just going to pick one at random, it tells you some basic information about this product. So this product is made out of wool and cellulose fiber from beechwood trees. And it tells you that it has some fire retardance properties, and it tells you how it's certified in the Cradle Cradle scorecard system. So this gets Cradle Cradle Silver, which is a pretty good label, and has a little more detail over here. And then it doesn't list the price of the material, but it does link to the company website and gives you the phone number, so you could find out from the company how much it costs, or you could call them and ask them for distributors. So sometimes you can buy stuff directly from companies, but sometimes you have to go through a distributor. But obviously the companies will be delighted to help you find a distributor that's relevant for you. And so that's basically it for the kind of information you get on here. And like you can see, there are lots of different categories here, and you can just flip through, browse through, and you can also search by maybe plastic or whatever. And so yeah, and that'll search within whatever category you're looking for. So if you go to all and do that same search, then you'll come up with a lot more stuff. So that's it for Cradle Cradle catalog. Then you can do similar things for the Fair Trade certified database. You click on there, and you can go by product category again. And here there's a lot of food. There's not so much like building materials or things that you can use in products, but But you can look around. For example, there's gold and precious metals. You can do a search on that and find a bunch of companies. So you click here. So yeah, just randomly click on one and gives you the name of the company, what kinds of products they do. So here's a place to get gold that is fair trade certified. This database is much more minimal, so you can't just click through to get to the company. You have to copy and paste to actually find info on the company. So you can go to their website and see what they do. But it's generally the same sort of thing. And if you look through here, so some of these are dedicated sustainable materials databases, but some of them are just normal material databases. And some of the materials in them have great sustainability properties, but others don't. And so like Material District, this is a good place to find materials generally, and some of them are green materials. So if we do a search for plastic in here, then you can see, once again, we'll have a left-hand sidebar that will let you filter things. So we could filter by plastics. And since we were already searching for that, it didn't really change much. But if we uncheck that and we check, let's say, natural materials with the word plastic searched for, then that brings up different stuff. And so like a coffee polymer, which is very exciting. And so if we click on this, then you can see we get lots of photos of what this is. And then it gives you some information down below saying what it's made out of. So 30% coffee grounds, 70% other bio-based raw materials. That's a little vague. That's not a great amount of info, but that's how it often is on websites like this. So you might have to do a little more due diligence to see how good this really is. But you can read their little blurb and why they think it's good. And then what's useful as a designer is websites like this will tell you various material properties for design, like how glossy is it? How translucent is it? Is it hard? What are the acoustics like? Does it smell like anything? And is it fire resistant or UV resistant, etc.? And so these kind of properties are really useful for you as a designer. And that's why it's often useful to search databases like this, even though there's not as high percentage of green materials in them. And again, you can go back, you could filter for other things. You could filter just by texture, like what are just smooth materials? And, so maybe you could find some recycled plastics. And again, you can get some info from the company on this and tells you what kind of products it's good for. And again, you have these material properties down here and shows when sometimes they vary, so you have different options. And again, this lets you filter by a lot of different stuff. So that's it for various catalogs of materials. Then databases and analysis software. Now, a lot of these could be entire videos of their own, but I'll just give you sort of a quick overview, like grant a CES selector. This is software that it might be too expensive for you as an individual, but your company might have a license of it, or your school might have a license of it. Let's just take a look at that. Now, when you start up Granta or CES EduPack, you'll get options for various different databases that you can choose. Basically, go with whatever the best database that you have for sustainability is. And, the data that you have is the data you have. And you can filter by various things. Again, if you're just looking for plastics, you could filter by that. Let's just start with all materials just for fun. And the quickest and easiest ways to find materials here is to make charts. So we can create a new chart here, and we can select the different axes. So for the y-axis, let's select the environmental impact of things. And there's not a whole lot of environmental impact data in CES, but there is some, like CO2 emissions per kilo of material. So we can go down to that category here and select the specific thing. We're looking for CO2 footprint per for primary production materials. And you can have a linear or logarithmic scale on the graph. And for the x-axis, let's choose some functional property that we want to filter by. Let's say we need some good material strength. So mechanical properties, and then let's say tensile strength. Okay? And so we're wanting to find a material of a certain strength or higher with a certain carbon footprint or lower. And yeah, again, let's try linear. And right now, this might take a while because it's looking at every material in the whole database. And it's kind of funny. You can see there's one giant outlier here. What is that? Diamond. Yeah, not too surprising that diamond has a giant carbon footprint with not super great tensile strength. And so we might want to edit the graph just to change back to the logarithmic scale that it was originally suggesting for us. Okay, because that makes it way more readable. Now we can see everything else on the graph. And here's diamond still there, but now that it's on a logarithmic scale, you can see everything else. So, okay, so what has a really high tensile strength, but a really low carbon footprint per kilo of material? Well, let's look here. Asbestos, maybe not our favorite material. What about this? Basalt, all right. Or mica, okay. Or what about this? Banana fiber, hey, I like the sound of that. Or flax fiber, ramie fiber, cotton fiber. Okay, so you get the idea. And then you can see other materials here, like tool steel. So you see all these sort of turquoise colors are different kinds of steel. And then non-ferrous metals. The blue is polymers, all these greens are foams, and et cetera, et cetera. So you can see the different material categories by color. And if you wanted to filter those, you could. But I'm going to show you one other way to make a chart that can be useful sometimes. So if you want, you can just look at certain categories of material. So rather than graph things by some numeric variable like CO2 footprint, you can graph things by kinds of materials. So let's say polymers. Okay, and then for the x-axis, let's make that one the environmental impacts. So primary production, CO2 footprint. And if we graph that, then first of all, you see that the list on the left here is just polymers, not everything like it was before. And you can see that it's just giving a list from best to worst. So whatever has the lowest CO2 footprint on the x-axis here. So the lowest one is PHA, bioplastic. There you go. And so you've got other ones like polypropylene, also low carbon footprint, and then things in the middle like EEA, TPO, polyamide, so nylon, and this is a 50% glass fiber. And then so what's at the top? What are the worst ones? Okay, peak with 40% carbon fiber. Sure, anything with carbon fiber is going to have a very big CO2 footprint. And so yeah, all these things up here are carbon fiber filled polymers. So you might want to use the granted database because it has more materials in it than an LCA database, but it has less sustainability data. But it has more ways that you can graph and filter and things like that. If we just want to look at things with a carbon footprint below 2 kilos of CO2 per kilo of material, we can make a little box selection and go 2 and below, so that cuts everything out. If we use this little hide failed records, that hides everything. And then if we auto scale the graph, then you can see that grows. And if we want to go back to our first chart, you can see that it's actually now filtered by the materials that we chose in our second chart, just the materials in this list over here. And so again, we can hide failed records and we can auto scale. And now we can look, okay, of everything that had a CO2 footprint lower than 2 kilos of CO2 per kilo of material, what are the tensile strengths? So what has the best strength here? Okay, this Novolac glass and mineral filled polymer, or just polypropylene, and various other things here. And like, what's something that performs really badly? Okay, styrene butadiene rubber has a weak tensile strength, sure, because it's an elastomeric material. But you could filter by other things if you wanted. You could filter by flexibility. You could filter by strength per unit weight. You could filter by really all kinds of things. And so that makes Granta a really powerful tool if you have very particular engineering requirements. And that's about it. So let's look back at other things. There's also LCA software. The nice thing about using LCA databases is that you can get more environmental information about stuff, like what has a lower land use or less water depletion, or a single score that combines lots of different environmental impacts into one number, like the recipe millipoints. But you don't have to use software to look things up in LCA. You can just use something like the equalizer lookup table. And so this is just a PDF, and it's a printable one too. You can have a physical one of these lying around. And you can just scroll through it for different materials. Or you can just search the PDF like you would search any text document. So can search it for plastic, and there are a lot of plastics, and you can see in the table of contents there are all these plastics on these different pages. So okay, I'll just click through until I get there. Okay, so here we go, plastics. And if I want to say what's a better or worse plastic, I can just look here and say, okay, these are all environmental impacts in recipe millipoints per kilo of material. So ABS plastic is 431 millipoints per kilo. Well, how does that compare to EVA? Well, this is 355, or polyamide nylon 756, polycarbonate 672, polyethylene 285, so that's way lower. So this is a much lower environmental impact material than the previous plastics that we've looked at. And the nice thing about looking in an LCA database is that you can then also compare the impacts of the material itself to various processing. What is it when it is extruded, or when it's injection molded, etc. So that's a quick way to compare materials using LCA data. And then the last thing here is chemical toxicity libraries. Now, this is actually not a great place to go finding new good materials, because this is often where you find bad materials. For example, the chemsec syn list, that is the substitute it now list, but there's a reason that it's called the syn list. And it's basically where you find chemicals of known hazard. And so if we do a search for something here, let's say not all ketones are bad, but a bunch are, so I know that some will come up here. And so you'll see various chemicals, and if you click on any one of them, it will tell you, what the name of that chemical is, the CAS number, and why it's on the list. That's the main thing. So this one is carcinogenic and persistent, and also has endocrine disruption. And so that's about all you need to know. But then it has various other stuff of like what product categories might use this chemical, and various other stuff like companies that make it. But basically, if your chemical is on this list, you don't want to use it. And so that's why this is usually not a great place to find new good materials. But some databases you can find some good materials in as well. So Pharos, for example, it has all kinds of chemicals in it. So if you look for, say, lactic acid, so that is a chemical that is actually pretty darn good. It's color coded by green is good, yellow is moderate, red is bad, and gray is unknown. But most of the things here are green. And so this is definitely a better chemical than if we did a search for formaldehyde. Okay, you would see that. You can see there's way more high hazard going on here. So you can use Pharos to find good chemicals as well as bad ones. And sometimes you can find whole products or larger material composites in Pharos as well. Like if we do a search for flooring, let's say, and you'll see it starts out by trying to find chemicals with that name, which is not what we're looking for. But if you click on products, then it'll list various products that it has with that name. And so we could look at cork flooring and see all the various ingredients of it. And oh, look, formaldehyde is one of the ingredients in this cork flooring, okay? But we can see the scores of the other ingredients as well. So the formaldehyde was a green screen benchmark 1, which is bad. That's the worst score. And then the other scores, also probably bad, unknown, not scored. So that's not great. And so we look at the various other things in this product, and they're pretty much all not good. But if you pay for the professional version of the database, then you can compare it to other things. So you could do a comparison of that cork flooring to bamboo and acrylic and linoleum, stuff like that, without having to go back and forth between them. And here I'm clicking on them individually to go through and look through what all the scores are. So you can use Pharos to find good materials as well. So that's basically what it's like to find greener materials. Like I said, it's not rocket science. It's just digging through websites for details and occasionally calling a company for prices, or calling them to find who their distributors are that you could get prices from. And You can find everything from 100% organic denim to mushroom packaging material to plastic made from coffee waste. You can find some very exciting stuff. And it's really all in the details. But you can't make sustainable products without sustainable materials.